my YouTube channel. This is Decagon Maths. In today's video, I'll be showing us how to solve an exact equation. In my previous video, I've explained how to determine if a given equation is exact or not. If you have not gone through that, so I'll leave the link in the description. Please ensure that you check it out so that you can have a full understanding on what we'll be doing here, right? So now we are given this. Now this is called the total differential of this function f, and that is written as the partial derivative of f with respect to x dx plus partial derivative of f with respect to y dy. Now don't worry if this is not making sense to you. The most important is you knowing how to apply it in solving problems, right? And I'll be showing us with making use of this problem so you can see how it is being applied. Alright, this problem we have to solve 3x all into bracket xy minus 2 dx plus x raised by 3 plus 2y all into bracket then dy equals to 0. Now to do this, the first step is that we check for the exactness. That is the first step we're going to take. So step 1, let's check for the exactness of this. So for our solution, the first thing we're going to do is to check for the exactness. Now to check for the exactness, we are going to determine our m. Our m here is 3x into bracket xy minus 2. Let's expand this bracket, that is 3x squared y minus 6x. Alright, then our n is equals to x raised by 3 plus 2y. I've studied that our m is the one always with dx and our n is the one always with dy. Alright, and the next thing to do is let's find our partial derivative of n with respect to x, and that is we have 3x squared y minus 6x with respect to y. It should be with respect to y. So we have, now when we do this, that means we are taking x as constant, right? That means 3x squared is identified as constant. So we are going to differentiate just y. So when we differentiate y, we have 3x squared. I've explained all of this in the previous video. So it's very important that we check out the previous video so that you can understand this concept very well. So this is 3x squared because when we differentiate y, it becomes 1, right? And this 6x is a constant, right? There is no y, so this is a constant throughout. So when we differentiate the constant, it becomes 0. You know that. Now here we have just 3x squared. So that means the partial derivative of m with respect to y is equals to 3x squared. Now let us find the partial derivative of n with respect to x. That is equals to we have x raised by 3 plus 2y with respect to x. Alright, so now doing this, that means we take y as constant. So when we differentiate x raised by 3, it gives 3x squared. Then when we differentiate 2y, it becomes 0 because it's a constant throughout 2y. The product of 2 and y is a constant, so that becomes 0. So we can see here that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, which is equal to 3x squared. So this is the condition for an equation to be exact, right? Since it has satisfied this condition, then we can solve making use of the method that we're going to be using now. I will show you can now proceed to solving the exact equation. Now let's move on to the second step. So for step 2, now what do we do for the second step? Now we're going to compare this side. I'm going to compare it to this side. Alright, so we're going to write that the partial derivative of f with respect to x dx is equals to 3x into bracket xy minus 2 dx. Now what we're trying to say here is that there is a function such that when we differentiate it with respect to x, partially with respect to x, it will give us this. Don't mind this now. Dx can cancel out, right? Obviously, dx can cancel out. So what I'm trying to say is that there is a function f such that when we find the partial derivative with respect to x, it will give us this, right? That is the interpretation of this when we compare this to this. All right, now let me put back the dx. Now, then if we have differentiated this partially to get this, then we can integrate both sides so that we can get back our function f. Alright, now let's integrate both sides. That means we have this using the derivative of f with respect to x dx is equal to this, that is 3x bracket x y minus 2 dx. Alright, so you write that f, that is the function, f now equals to, now this is, now expand this bracket, this gives 3x squared y minus 6x dx. Alright, now we are integrating here partially with respect to what? With respect to x. That means every y here will be taken as constant again. Alright, so we can write this as 3x squared y dx minus integral of 6x dx. Okay, now this, since we are taking y as constant, right? That means we can write y 3y out. 3 and y are constant in this case. So we have 3y, so integral of x squared dx minus, so we can write 6 here is the constant, then x dx. Alright, so now we have 3y, and when we integrate x to the power 2, it becomes x to the power 3 over 3, right? We have x to the power 3 over 3 minus this. When we integrate x, it becomes x squared over 2. Then what will be our constant? We know that y is the one taken as a constant. So our constant in this case will be a function of y, because y is our constant all the time. In this case, when we are differentiating partially, integrating partially with respect to x, or even when we are differentiating partially with x, we know that in that case, the other variable is taken as constant, which is y. So if y was our constant, y differentiating partially, then when we are also integrating, y will also be our constant. But you can't just say y. It is not yet given or defined. So we can just represent it generally as f of y. So we are going to write f of y here, which will be our constant. Now, so let's tidy this up. We have now 3 cancels 3 here. We have x to the power 3y. Then 2 here 1, 2 here 3. We have minus 3x squared plus f of y. Alright, now what is the next thing for us to do? Now the next thing we are going to do here, which will lead us to step 3, is that we are going to differentiate this that I obtained with respect to y. Alright, so let's take this as our equation 1. So for space, let's delete this side. Alright, so we have step 3. So this is f, right? So we are going to differentiate ef partially, we are doing that partially with respect to y. So that equals to, we are going to differentiate this one, x to the power 3y minus 3x squared plus f of y with respect to y. Alright, and remember here that this simply means that we will take x as constant, right? Alright, so that means the final derivative of f with respect to y equals to, now when we differentiate y, it becomes 1, right? So we have just x cubed here. So that is x to the power 3. Now this minus 3x squared is all constant. So this term will be gone. You don't need this term again, right? So we have x raised to power 3, then we move on to the next term, f of y. Now, remember that we integrated to find f of y, right? So when we differentiate again, we get f prime of y, right? So when we differentiate f of y, we get f prime of y. So that's that. So let's take this as equation 2. Now we are done with step 3, and let's go to step 4. So what are we doing with step 4? Now this is partial derivative of f with respect to y, and that's what we have here, right? Since what we have here is what we have here, definitely is also comparable to this, right? So that means what we have here are equal. So that means we have that x raised to power 3 plus f prime of y is equals to x raised to power 3 plus 2y, right? Now what we're going to do here now, we are going to make f prime of y the subject of formula. So we have that f prime of y equals to x raised to power 3 plus 2y minus x raised to power 3. So this two terms cancels out, right? We have f prime of y equals to 2y. Now what we do now is we integrate both sides with respect to y. That means we integrate f prime of y with respect to y, 2y dy. Now this goes back to f prime of y, right? So when we integrate this, it goes back to its initial form. Sorry, y here. Now equals to, when we differentiate this, we have 2y squared over 2 plus c, which is also equal to y squared plus c. Now let's call this equation, that will be our equation 3, right? Yes, that will be our equation 3. Alright, now what do we do here? Now we go back to equation 1. We are going to put this equation 3 into equation 1 that we have here. Right? Can you see that? So when we put f of y in this, then we have completely our function f. So putting that in equation 1, so that will be, let's take that as our last step, which is step 5. Put 3 into 1. So that means we have that f equals to x raised to power 3y minus 3x squared, and plus we have y squared plus c. So this gives us our complete function that we are looking for. So this is the solution to this equation given. If you have to determine the exactness and then find the solution, then you have done that now. Thank you guys for staying through. You have come to the end of this video. If you know you like my content, please subscribe to my channel, and then please comment, like, and share this video. Thank you. See you next time. Goodbye.